Problem 4 states that the voltage waveform shown in the figure was observed at the sending end of the lossless transmission line in response to a step voltage. If Zg is equals to 80 ohms and Z0 is equals to 50 ohms, calculate the generator voltage and the length of the line and the length of the line. Assume U is equals to C. Now this problem is similar to the problem 3 that we have already solved. So if this is Z equals to 0 and if this is Z is equals to L, then we are given V 0 comma T in this plot here. Okay, so what it says is at T is equals to 0, the voltage is 10 volts. Now we know that the moment the switch is closed, that is at T is equals to 0, the generator voltage just sees Zg and Z0. Okay, so we know that therefore the voltage at this point, let's say it's V1 which is equals to V0 comma T is equals to Vg divided by Zg plus Z0 multiplied with Z0. It doesn't see the load at this end at the very moment T is equals to 0. Okay, so if that's the case, we know that this voltage is equals to 10 volts from the graph here. Okay, from the graph here. So we know that Zg is equals to 80 ohms, Z0 is equals to 50 ohms, V1 is equals to 10 volts. What is Vg? Okay, therefore Vg is equals to V1 into Zg plus Z0 divided by Z0. That is equal, that is going to be 10 into 80 plus 50 divided by 50. That is going to be 10 into 130 divided by 50. 10 ones are 10, 10 5s are 5, 5 ones, 5 2s are 10, 20, 10, 30, 26. So that's 26 volts. Therefore, Vg is equals to 26 volts. So now we know that the voltage V0 of t changes to some value 7 volts at 4 microseconds. So how is that going to happen? The voltage V first travels along this line and takes a finite time t and gets reflected back. Okay, during all this time V1 is constant, and once it gets reflected back, then it reflects back again towards the load. It is at this point of time that actually the voltage changes. So this is another t. So for 2t, after 2t is when the voltage changes. So we are given that 2t is equals to 4 microseconds. That is also equals to the distance traveled along the transmission line. So that is basically equals to 2t is can be written as L by U. We know that U is equals to C in this particular case, so that is equals to 2L by C. Therefore, 2L by C is equals to 4 microseconds. 2L is equals to 4 microseconds into 3 into 10 to the power 8 meters per second. So that is L is equals to 4 into 10 to the power minus 6 into 3 into 10 to the power 8 divided by 2. So that is going to be 2 2s are 2. So we have 3 2s are 6. 6 into 10 to the power 2 meters. Okay, so that's 600 meters. Okay, that's about the length of the wire or the transmission line. Okay, part B asks us what is the impedance of the load. Now how do we find that? We have to follow the same method that we followed in problem 3. I'll just go over it. So we know that at time t is equals to 0, we had, let's just draw the bounce diagram. Okay, we had a voltage of 10 volts. Okay, 10 volts, and at 2 microseconds it reached the load side, and then some voltage got reflected back from the load to the source side. We don't know what this is. It depends on gamma L. Gamma L is ZL minus Z0 divided by ZL plus Z0. So let's say So we know that gamma L is the reflection coefficient. Let's say 10 gamma L gets reflected back. Now, once it gets reflected back at 4 microseconds, we see that this voltage again reflects back to the load side from the source. So then that is going to be 10 gamma L gamma G. But we know what gamma G is, that is equals to Zg minus Z naught divided by Zg plus Z naught. It's given in our problem that Zg is 80 ohms. So that is going to be 80 minus 50 divided by 80 plus 50. That is going to be 30 divided by 130. So 30 divided by 130 is going to be equal to 0.23. Okay, so let it be whatever it is. But we know that, so the voltage that is reflected is 10 gamma L gamma G. But we know that at this point, right after the 4 microseconds, we know what the voltage is. We know that the voltage is 10 volts plus 10 gamma L plus 10 gamma L gamma G, which is equals to, it is given in the problem statement to be equal to 7 volts. Okay, that's on the source side. So this is 7 volts. Now all that we have to do is find out gamma L from this one. So once we know gamma L, we can find what ZL is. So 10 plus 10 gamma L plus 10 gamma L into 0.23 is equals to 7 volts. Now if we solve this equation, gamma L is equals to minus 2.439. Okay, this is gamma L. Now we know gamma L is equals to ZL minus Z naught divided by ZL plus Z naught, which is equals to minus 2.439. If we substitute these values for Z naught, we will find that ZL is equals to 30.39 ohms. Thank you.